Hey everyone, Nitesh this side. Hope you're doing good. So let's start with the question. So the question is search in a binary search tree. Okay, so finally three questions are coming. So you are given the root of the binary search tree and an integer value. What you have to do, you have to find the node in the binary search tree that node's value equal to the value that is given to you. And you have to return the subtree rooted with that node. If such node does not exist, you have to return null. Basically, if you find any node which value is equal to the given value that that is mentioned in the question, you have to just return that node only. Okay, so let's see for this example. As you can see, this is a tree 42713, and it's a binary tree and it's a binary search tree. Okay, so you have to search value 2. Okay, so what you can see, 4 is there, then 2 is there. So your your node value is matching with the value, so you will just return this node and you just have to return the node only. Okay, let's see for another example. For this case, if you can see, we have to search for value 5. As you can see in the example, value 5 is not there, so we just have to return null at that point. Okay, so how can we approach this question is, if it is a normal binary tree, what we have to do, we have to go, like, we have to search in the node, basically root node, then we have to search its left, and then we have to search its right also. Okay, because in normal binary tree we are not sure whether they are maintaining some ordering. Okay, but in binary search tree there is an ordering. Okay, so as you can see, the root element, the left element to always this is always lesser in binary search tree, and the right element to your root node is always bigger than that. Okay, so as you can see, this 4 is a root node. Okay, and if you see the left value of all the node 1 2 3, they are lesser than this. Okay, so what we, and right is bigger than that. Okay, if you see the for second node also, for second, the lesser node is always on the left side, which is 1, and the bigger node is always on the greater side, so that is 3. Okay, so by given a binary search tree, we can basically optimize our previous approach by not going to the left or right. We can go only in one direction. Okay, how can we check? So what we will do, we will start from here, from the root node, and we will compare it with the value. Okay, so if it is matching with the value, we just return node. If not, we will check whether this value, whether the given value, is it greater than the root node. Okay, so if it is greater, then the chance of getting the element should be in the right side, because if the given value is greater than this, it should not be here, because we know all the elements are there in the left side are smaller and right are bigger, so chances of getting the element, so we will search in right. Similarly, if the given value is less than, you can say, the root node, we will go to its left direction only. We will not go in the right direction, because right have all the bigger element. Okay, so you will go to left, you will come here, you will compare it with the value. So as you can see, this is matching, so you just return the node. Okay, so this looks like a simple question. So what we will do, we first step, what we have to do, we have to compare root dot value is equal to value. Okay, if it is equal to, just return the node. Okay, we will just return root. Okay, if not, else if, what you have to do, if your root dot value is greater than value. Okay, so your given value basically is lesser than the current node. So what you have to do, you have to go to the left side, because the given value is lesser, so chances of getting the element should be in the left side. Root dot left, and we'll just give the value. Okay, else if the value is greater, so we have to search in the right part. BST root dot right value, and we have covered all the recursion case. So there should be a base case also. So what will be the base case? Let's say you go left, you go right, I like either way of them, but at the end, if you didn't get the element, you will reach to the null. Basically, if you go after this, you will go to the either left is also null and right is also null. Okay, so what we will do, if our root is equal to null, we just return the null from here. Okay, so I think we have covered all the cases. Let's run it. Let's see if it can accept it. This is accepted. Let's submit it. Okay, taking so much time. So our code is submitted. The time complexity is so either you are going to the left or either you are going to the right. You are not going to all the events. So for the time complexity, it's bigger high. If you go like, let me just. So let's say if you have to search 3, you will go from 4. You will come at this direction, then 2, then you will come at this direction. So you will go at max at the height of the tree. Okay, so the time complexity for this is your order of height of the current route, and space is just a recursion space. So yeah, hope you like it. Thank you for watching my video, and do join the Telegram group if you're in doubt and any concern. Thank you.